This notes page is actually going to take up 2 videos. The first video is video 4, Pythagorean identities in Unit 8. And in this video, we are going to examine the Pythagorean identity and how it can be used to algebraically determine other formulas. So the first thing I want you to look at is that, excuse me, that we have this formula that we've used in the past, that we have sine squared plus cosine squared equal to 1. And that's true for all values, and we got that from using the unit circle and the idea that we have a right triangle and that we have x squared plus y squared is equal to 1. And we are going to primarily memorize this idea of sine squared plus cosine squared equal to 1, and we can use it to answer these questions. The angle has its terminal ray in the second quadrant, and sine of theta equals 5/13. Algebraically determine the value of cosine. So the nice thing about doing these questions is that you could draw a triangle to help you. So here is our triangle. And if we mark one of our angles to be our theta, let's call it this one down here, this is theta, and this is our 90 degrees, we do know that sine is opposite over hypotenuse. So that means that 5 can be opposite of our theta, which we can put here, and 13 can be our hypotenuse, which would be the slanted side. Now that just leaves one side of the triangle left to find, and that's this one down here. And we can find this using the Pythagorean theorem. And by doing that, you know that we have 5 squared plus x squared must equal 13 squared. And when you solve the Pythagorean theorem, you get x has to be 12. And some of you may have already known that. That's a pretty well-known Pythagorean triple. But beyond that, there's always 2 steps to these trig problems. We also have some important information that is given to us right here, that it's in the second quadrant, and that we need to find cosine. So I knew to draw the triangle because I know something about cosine. And I know that cosine of an angle is always going to be equal to adjacent divided by the hypotenuse. And so that means that the cosine of the angle of our theta here is going to be equal to 12 divided by 13, being that this adjacent side down here is now 12. But remember this other thing that I highlighted, saying that we're in the second quadrant? That means that we know that we're not actually finding just the reference angle idea, but that we're looking for the negative cosine of the angle. So that's going to be negative 12/13. And that's all there is to using the Pythagorean identity. Now an identity, just so that we have a definition here, is that identity is something that is always true for all values of the variable. Okay, it's kind of like 1x plus 1x equals 2x. It doesn't matter what x I put in there, that is always going to be true, so it's an identity. So this is the first identity. We have several more identities that we're going to use to solve for lots of trig thetas, so you have to be careful about which one you choose and try to understand why we're choosing it. This concludes this video, and on to the next.